We're going to evaluate hyperbolic functions here, and we're looking at the hyperbolic sine of 4. My scientific calculator does not have a hyperbolic sine button, but we do have a definition that says that the hyperbolic sine of x is equal to e to the x minus e to the negative x over 2. Therefore, the hyperbolic sine of 4 is equal to e to the fourth minus e to the negative fourth over 2. That I can put in my calculator. It's approximately 27.3, and there we are. There's a part B to this exercise. Evaluate the hyperbolic sine of the natural log of 4. Again, using the definition, we're going to say that this is equal to e to the natural log of 4 minus e to the negative natural log of 4 divided by 2. Using properties of logs, we can express this as 4 minus 1/4 over 2, that 1/4 coming about because there's a property of logs that says that a coefficient in front of a logarithm becomes an exponent for the argument, and 4 to the negative 1 is 1/2. By simplifying the complex fraction and collecting like terms as appropriate, we get 15/8 as a result. Next, we're going to prove an identity involving hyperbolic functions. The hyperbolic cosine of the quantity of x plus y is equal to the hyperbolic cosine of x times the hyperbolic cosine of y plus the hyperbolic sine of x times the hyperbolic sine of y. This is like the sum formula for the cosine function, except that one has a minus in between the terms, and this is got a plus. The way we're going to prove hyperbolic identities is to use the definitions. So the hyperbolic cosine of x is e to the x plus e to the negative x over 2, the hyperbolic cosine of y. Same thing, but with y's in place of x. And then the hyperbolic sine of x is e to the x minus e to the negative x over 2. Hyperbolic sine of y, same thing, but with y's in place of x. Now we multiply, we use algebra, properties of exponents. So e to the x plus y plus e to the x minus y plus e to the negative x plus y plus e to the negative of the quantity of x plus y, just factoring out that negative, all over 4. That takes care of the first two factors there, plus the result of performing the same kind of multiplication with the second term. And we end up with, instead of pluses in front of the e to the x minus y and e to the negative x plus y, because we had two differences that we were multiplying together, those are minuses. And I see that I wrote a denominator of 2, and it should be 4. Combining fractions and collecting like terms, we have a fraction with a single denominator of 4. And e to the x plus y plus e to the x plus y is going to give us 2e to the x plus y. And we have a nice situation that occurs. E to the x minus y is in the first fraction. Negative e to the x minus y is in the second fraction. They subtract out. Likewise, e to the negative x plus y minus e to the negative x plus y subtracts out. And finally, e to the negative x plus y shows up twice, so we have 2 times e to the negative quantity of x plus y. Reducing this fraction gives us e to the x plus y plus e to the negative of the quantity of x plus y over 2, which exactly matches the definition of the hyperbolic cosine of the quantity of x plus y. So really, to bring this all home, I should have started the whole thing with the hyperbolic cosine of x times the hyperbolic cosine of y plus the hyperbolic sine of x times the hyperbolic sine of y is equal to everything that we just did. And so I'm going to do a little cheat here. Copy and paste this. We end up with the two sides of the equation equaling each other as expected.